June 19th, 1943, Republic Aviation Factory, Farmingdale, New York. The P-47 Thunderbolt sat in the testing bay, its massive 18-cylinder radial engine exposed as technicians swarmed around it like mechanics attending a wounded fighter. Chief Engineer Alexander Kartveli watched from a distance, arms crossed, his face betraying nothing of the turmoil within. The latest combat reports from the 8th Air Force were troubling. German fighters were outclimbing the massive American fighter above 25,000 feet, precisely where bomber formations needed protection. What if we push it further? The voice belonged to Robert Sanator, a young mechanic who'd joined Republic after 3 years at Pratt Whitney. The R-2800 has more to give. Kartveli turned to face him. The Supercharger is already operating at maximum safe pressure. Any higher, and we risk catastrophic failure. Sanator didn't back down. I've been studying the General Electric Supercharger. It's overbuilt, designed with safety margins we're not utilizing. I believe we can extract another 400 horsepower without compromising reliability. The chief engineer's eyes narrowed. Show me your calculations. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments where in the world you're watching from today. What followed would challenge everything the aviation industry believed about engine power limitations. The realization didn't come as a thunderbolt, but as a creeping understanding that grew with each calculation. The P-47 Thunderbolt, affectionately called the Jug by its pilots for its milk bottle shape, was already the heaviest single-engine fighter in the American arsenal. Weighing over 7 tons fully loaded, it carried 8 .50-caliber machine guns and could absorb punishment that would destroy most fighters. But its true revolutionary feature was hidden behind the massive 18-cylinder Pratt and Whitney R-2800 double-wasp engine, a General Electric turbo supercharger that forced compressed air into the engine at high altitudes where oxygen was thin. This system already gave the P-47 excellent high-altitude performance, but Sanator believed they were being too conservative. The supercharger operated by capturing exhaust gases and using them to drive a turbine, which in turn compressed incoming air before it entered the engine. More compressed air meant more power, but also more heat and stress on components designed for lower pressures. Look at these safety margins. Sanator pointed to his calculations. The supercharger housing is built to withstand 30% more pressure than we're using. The impeller blades have similar reserves. GE was being cautious, understandably so, but we're fighting a war. We need every advantage. Kartveli studied the numbers carefully. The young mechanic had done his homework. If you're wrong, we'll lose engines, possibly aircraft and pilots. Sanator nodded grimly. If I'm right, we'll gain the high-altitude advantage our bomber boys desperately need. The chief engineer made his decision. Prepare a test engine. Full instrumentation. I want to see exactly what happens when we push beyond the red line. What the Republic aviation engineers discovered in the next 48 hours would challenge everything they believed about engine power. Limitations. The test began at dawn. The massive R-2800 was mounted in a specially designed test stand, connected to instruments that would measure every aspect of its performance. Coolant temperature, oil pressure, manifold pressure, supercharger turbine speed, exhaust gas temperature, nothing would go unrecorded. Engineers and mechanics gathered behind blast shields as Sanator made final adjustments to the supercharger wastegate, the valve that controlled how much exhaust gas flowed to the turbine. Normally set to maintain a specific maximum pressure, today it would be gradually closed, forcing more exhaust through the turbine, spinning it faster, generating more boost pressure. The engine roared to life, settling into a smooth idle that belied the 2,200 cubic inches of displacement. 18 cylinders arranged in 2 rows, each one larger than an entire motorcycle engine. Sanator signaled the test engineer to begin the procedure. The throttle advanced slowly as the engine RPM climbed. At normal military power, 2,000 horsepower, everything appeared normal. Instruments showed expected readings across all parameters. Then Sanator began closing the wastegate. The effect was immediate. The engine note changed, becoming harder, more urgent. Manifold pressure, the measure of how much air was being forced into the cylinders, climbed past 60 inches of mercury, well beyond the factory limit of 52. The supercharger turbine spun faster, its pitched scream rising above the engine's roar. Temperature gauges began, climbing. 2,100 horsepower, 2,200, 2,300. Warning lights illuminated on the test console. The engine was now generating power well beyond its rated maximum, but it continued running. Oil temperatures climbing fast, called out an engineer. Cylinder head temperatures approaching limits on cylinders 1 and 2. Sanator watched the gauges intently, making minute adjustments to the wastegate. The power output climbed to 2,400 horsepower. The entire test stand vibrated with energy as the massive engine strained against its mounts. At 2,500 horsepower, 25% beyond the engine's rated output, Sanator held up his hand. "Hold here. Let's see if it stabilizes." Minutes passed as the engineers watched temperature gauges with growing concern. The oil temperature stopped climbing just below the absolute maximum. Cylinder head temperatures likewise stabilized just short of the life danger point. The supercharger housing glowed dull red in places, but the specially installed temperature sensors showed it remained within structural limits barely. After 10 minutes of sustained operation at this unprecedented power level, Sanator gave the signal to reduce power. As the engine returned to normal settings, a spontaneous cheer erupted from the engineering team. Kartveli approached, his face still serious. It ran, but for how long would it run in combat conditions? 10 minutes? 20? An hour? Pushing mechanical systems this far reduces service life dramatically. Sanator had anticipated this objection. "We're not suggesting running at this power level continuously. This would be an emergency war, emergency power setting used only when absolutely necessary, for perhaps 5 minutes maximum, when a pilot needs to escape or gain a critical advantage in combat." The chief engineer considered this. "Even so, we'd need to rebuild engines after perhaps every 5 to 10 missions." The young mechanic's response was direct. How many rebuilt engines equals one lost bomber with 10 men aboard, or a P-47 pilot shot down because he couldn't climb fast enough? This was the fundamental question. American industry could produce engines faster than Germany could shoot down aircraft. American training programs were graduating pilots faster than they were being lost. The mathematics of attrition favored using equipment to its absolute limits if it meant saving lives and winning battles. 2 more days of testing followed. Engineers documented exactly what happened to the engine under these extreme conditions. Metal fatigue appeared more quickly. Valve springs showed stress after just 20 hours of operation that would normally take 100 to develop. Oil consumption increased by 30%. But catastrophic failure did not occur. The R2800 proved remarkably robust, even when pushed far beyond its intended limits. The findings were compiled into a detailed report. Sanator's modification, which came to be called War Emergency Power, could increase the P-47's power output from 2,000 to nearly 2,500 horsepower for short durations. This would dramatically improve climb rate and acceleration, exactly where Thunderbolt pilots needed it most, above 25,000 feet, where bomber formations flew, and where German interceptors held advantages in power-to-weight ratio. Kartveli presented the findings to Republic's management and representatives from the Army Air Forces. The modification requires minimal changes to existing aircraft, a simple adjustment to the Supercharger wastegate control and replacement of the manifold pressure gauge with one that reads higher. We can implement it immediately on the production line and retrofit it to aircraft already in service through a simple field modification kit. The military officials exchanged glances. One colonel spoke up. "What's the downside?" The chief engineer was forthright. Increased maintenance requirements, more frequent engine rebuilds, higher fuel consumption. And if pilots exceed the 5-minute limit at war emergency power, they risk engine failure. The room fell silent as the implications were considered. Finally, the senior military representative nodded. The 8th Air Force lost 60 bombers in the Schweinfurt raid last week. Each bomber has 10 men. If this modification saves even a fraction of those losses, by giving our escort fighters the performance they need, the maintenance cost is acceptable. By August 1943, the first modified P-47 seconds were arriving in England. The modification kit consisted of a new manifold pressure gauge that read up to 80 inches of mercury, with the normal military power limit of 52 inches marked in red, and the new war emergency power limit of 70 inches, marked in black. Pilots received briefings on the new capability with strict instructions. Use it only when absolutely necessary, for no more than 5 minutes, and report its use immediately upon landing so maintenance crews could inspect the engine. The first combat test came on September 6, 1943. Captain John Thompson of the 356th Fighter Group was escorting B-17 seconds to Stuttgart when his flight was bounced by Messerschmitt 109 seconds from JG-3. Outnumbered and separated from his wingman, Thompson found himself with 109 seconds on his tail. The P-47's normal tactic in such situations was to dive away, using its superior weight and power to escape. But Thompson was the last fighter between the German interceptors and the bomber formation he was protecting. He had received one of the modified Thunderbolts just 3 days earlier. Rotating the throttle grip fully forward and pulling the red knob that controlled the wastegate, he pushed the manifold pressure beyond the red line to the new war emergency setting. The response was immediate and dramatic. His Thunderbolt surged forward, the additional 500 horsepower translating directly into acceleration and climb rate. The engine's pitch changed to a threatening growl as the supercharger forced more air into the straining cylinders. Thompson pulled into a climbing turn that would normally have bled off airspeed rapidly in the heavy fighter. Instead, the P-47 maintained its energy, climbing through 30,000 feet at a rate that shocked the pursuing German pilots. One of the 109 pilots, pressing his attack, found the tables suddenly turned as Thompson's Thunderbolt pulled away climbing, then rolled over into a diving attack position. The German aircraft scattered, their calculated advantage in high-altitude performance suddenly erased. When Thompson landed, he immediately reported using the war emergency power setting. Maintenance crews swarmed over his aircraft, checking the engine for signs of stress or damage. Oil samples were taken and analyzed. Compression tests performed on all 18 cylinders. The verdict: the engine had survived its baptism of fire. It would need closer monitoring and would likely require overhaul sooner than standard engines, but it had performed exactly as Sanator had predicted. Word spread through the fighter groups. The modified P-47 seconds were dubbed Superjugs by their pilots. In the weeks that followed, more combat reports filtered in. Lieutenant William Dunham of the 62nd Fighter Squadron used war emergency power to outclimb a Focke-Wulf 190 over Bremen, turning a deadly disadvantage into his fifth aerial victory. Captain Raymond Knight escaped 4 Mi-109 seconds by using the extra power to accelerate away in a shallow climb, a maneuver that should have been impossible in the heavy American fighter. Not all experiences were positive. Staff Sergeant Michael Donahue, a maintenance chief with the 368th Fighter Group, documented the toll the modification took on the massive radial engines. Valve seats show accelerated wear after just 3 uses of war emergency power. Piston rings are losing tension faster. Oil consumption is up 30 to 40% across the board. These were manageable issues in the context of the European Air War, where American production capacity meant replacement engines were readily available, but they confirmed the modification had real costs. By October 1943, Republic Aviation was incorporating the lessons from the field. Engineers redesigned valve seats using more durable alloys. Improved piston rings with better heat resistance were introduced. Oil coolers with greater capacity were fitted to production aircraft. Each change incrementally reduced the maintenance burden while maintaining the critical performance advantage the modification provided. This iterative improvement process, implementing a capability immediately while continuously refining it, exemplified the American approach to wartime engineering. The true impact of the modification became apparent during the second Schweinfurt raid on October 14, 1943. The previous Schweinfurt mission in August had cost the 8th Air Force 60 bombers, a catastrophic 25% loss rate. The October raid, while still costly with 26 bombers lost, showed a marked improvement despite facing similar numbers of German interceptors. Post-mission analysis credited the improved high-altitude performance of the escort fighters, particularly the modified P-47 seconds, with preventing an even higher loss rate. Colonel Hubert Zemke of the 56th Fighter Group, one of the most successful P-47 units, submitted a detailed report to 8th Air Force headquarters. The war emergency power modification has transformed the Thunderbolt from an adequate high-altitude escort to an exceptional one. Where previously our pilots had to be defensive above 28,000 feet, they can now confidently engage the Luftwaffe on at least equal terms at bomber altitude. This single change has saved aircraft and lives. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The modification program expanded rapidly. By November 1943, nearly all 8th Air Force P-47 seconds had received the upgrade. Republic Aviation incorporated the changes into the production line, delivering new aircraft with the capability already installed. The company's test pilots continued pushing boundaries, exploring what was possible with the massive R2800 engine and its turbo supercharger system. On December 3, 1943, test pilot Ronald Sinclair took a specially modified P-47 to 45,000 feet, almost 8.5 miles above the Earth, setting an unofficial altitude record for single-engine fighters. German intelligence soon became aware of the American fighters' improved performance. Captured, Luftwaffe pilots expressed surprise at the P-47's new capabilities. One Messerschmitt pilot, shot down over Belgium in November, told his interrogators, "The Thunderbolt we were briefed about could not do what the one I encountered did. It climbed away from me above 30,000 feet. This should not be possible for such a heavy aircraft." Maintenance crews continued documenting the effects of war emergency power use. The data showed that engines operated at the extreme setting for the full 5 minutes allowed generally required overhaul after 3 to 5 missions. This was a significant maintenance burden but deemed acceptable given the tactical advantage provided. As one maintenance officer noted, "We're replacing engines instead of pilots." The engineering success behind the P-47's power upgrade represented a fundamentally American approach to wartime technology development. Rather than pursuing theoretical perfection, Republic's engineers had identified a practical improvement that could be implemented immediately across the fleet. They accepted increased maintenance requirements as a reasonable trade-off for enhanced combat effectiveness. This pragmatic philosophy, choosing adequate solutions now over perfect solutions, later characterized American war production across all sectors. By early 1944, the war emergency power modification had been implemented across all combat theaters where P-47 seconds operated. Reports from the 15th Air Force in Italy, the 5th Air Force in the Pacific, and the 9th Air Force supporting the build-up for the invasion of Europe all confirmed the value of the upgrade. A routine modification, conceived by a young mechanic who questioned established limitations, had meaningfully altered the air war's dynamics. Robert Sanator received little formal recognition for his contribution. A brief commendation in his personnel file and a modest bonus were the extent of the official acknowledgement. Like many technical innovations during the war, the improvement was considered simply part of the ongoing effort to maximize the effectiveness of American equipment. After the war, however, aviation historians would identify the P-47's war emergency power modification as a critical factor in establishing air superiority over Europe in late 1943 and early 1944. The story of the P-47's Supercharger modification illustrates a broader truth about American engineering during World War II. Innovation came not just from design bureaus and research laboratories, but from mechanics on factory floors and in field maintenance units. The hierarchies that might have stifled such bottom-up innovation in peacetime were flattened by the urgent demands of war. When Sanator approached Kartveli with his proposal, the chief engineer listened not because of the young mechanic's credentials, but because the idea might save lives and help win the war. This democratization of innovation, combined with America's immense industrial capacity, created a uniquely powerful technological ecosystem. Ideas could move from concept to implementation with remarkable speed. The entire war emergency power program from initial proposal to fleet-wide implementation took less than 6 months. No committee meetings, no extended study periods, no bureaucratic delays. The need was identified, a solution proposed, tested, and implemented. As 1944 progressed, the modified P-47 seconds played a crucial role in establishing Allied air superiority over Europe. The ability to fight effectively at bomber altitudes meant German interceptors could no longer attack with impunity. Every engagement was now contested, forcing the Luftwaffe to commit more resources to each interception attempt and increasing their losses. The war of attrition in the skies turned decisively in the Allies' favour, exactly as the architects of the strategic bombing campaign had envisioned. The story of how one mechanic's dangerous idea transformed the P-47 from an adequate escort fighter to a dominant high-altitude performer remained largely untold for decades after the war. The modification was considered simply one of countless incremental improvements made to American aircraft during the conflict. But for the bomber crews who saw P-47 seconds staying with them all the way to the target and back, and for the fighter pilots who found themselves able to fight on equal terms above 30,000 feet, the impact was anything but incremental. In 1976, aviation historian Martin Caden tracked down Robert Sanator, then retired after a long career in aerospace engineering. When asked about his wartime contribution, Sanator was characteristically modest. "I just saw an opportunity to get more from what we already had." The real credit belongs to the Pratt Whitney engineers who built such a robust engine in the first place, and to the maintenance crews who kept those engines running, despite how hard we pushed them. The P-47 Thunderbolt would go on to become one of the most successful fighter aircraft of World War II, with more than 15,000 built. Its combination of firepower, ruggedness, and high-altitude performance made it a versatile weapon on all fronts. The war emergency power modification that pushed its already powerful engine to new limits was just one factor in that success, but a significant one that came at a critical moment in the strategic bombing campaign. The broader lesson of the P-47 Supercharger story extends beyond aviation engineering. It demonstrates how war demands solutions that balance theoretical perfection against practical reality. The modification traded increased maintenance requirements for immediate combat advantages, a calculation that made sense only in the context of America's overwhelming industrial capacity. Republic Aviation could implement the change precisely because American factories could produce replacement engines faster than they would wear out, even with the increased stress. January 4th, 1944. 8th Air Force Headquarters, High Wycombe, England. Colonel Hubert Zemke studied the combat reports with growing satisfaction. The numbers told a story that would have seemed impossible just 6 months earlier. Since the implementation of the war emergency power modification to the P-47's turbo supercharger, Thunderbolt pilots had achieved a 30% increase in kills against Luftwaffe fighters above 30,000 feet. More importantly, bomber losses during escort missions had decreased by 25%. The modification had transformed the air war over Europe. "These figures confirm what we're seeing in the field," Zemke told General William Kepner, the newly appointed commander of 8 Fighter Command. "The Jug can now outclimb and outrun anything the Germans throw at us above 30,000 feet. Our bomber boys are noticing the difference." Kepner nodded, but his expression remained somber. "The modification is working better than we could have hoped, but we're discovering new problems. The maintenance burden is significant. Some groups are reporting engine overhaul requirements after just 5 missions with extended use of war emergency power." Zemke wasn't surprised. That was expected. Sanator and Kartveli were clear about the trade-offs. "We're replacing engines instead of pilots and bombers." His finger tapped the combat loss statistics. "Look at the mathematics. One R2800 engine costs approximately $8,000 and takes a maintenance team 48 hours to replace. One B-17 costs $300,000 and carries a crew of 10 men who require 6 months to train. If we burn through engines to save bombers, we're winning that exchange." This pragmatic calculation, measuring engine life against human lives, captured the essence of American war production philosophy. By February 1944, that philosophy was being tested on an unprecedented scale. The 8th Air Force was ramping up for Operation Argument, a series of massive daylight raids designed to destroy the Luftwaffe before the planned invasion of Normandy. The strategic stakes couldn't be higher. If Allied air forces couldn't achieve air superiority over Northern Europe, the invasion would face potentially catastrophic opposition from the air. The modified P-47 seconds would play a crucial role in this campaign, which would come to be known as Big Week. The true test of Sanator's modification was about to begin on a scale that would determine the course of the air war. While American fighters had proven increasingly effective in protecting bombers, the Luftwaffe still mounted formidable defenses, particularly when bomber formations penetrated deep into Germany. The modified P-47 seconds would need to escort bombers all the way to targets and back a mission profile that would push the engines to their limits. Maintenance crews being worked around the clock to prepare the fighters. Chief Master Sergeant William Harrington of the 356th Fighter Group oversaw a team responsible for 48 P-47 seconds. "We're implementing additional monitoring procedures," he explained to his squadron commanders. "Oil analysis after every mission, cylinder compression checks after any use of war emergency power, turbocharger inspections every 3 missions, regardless of whether emergency power was used." These precautions were necessary because pilots were pushing the aircraft harder than ever before. Lieutenant James Howard, who would later receive the Medal of Honor for single-handedly defending a bomber formation against 30 German fighters, described the effect of the modification. "The extra power transforms the jug. It's like switching from a draft horse to a thoroughbred in the middle of a race. When you close that wastegate and push beyond the red line, you feel the surge immediately. The trick is knowing when to use it and when to back off before you cook the engine." On February 20th, 1944, the first day of Big Week, 823 bombers took off from bases across England, bound for aircraft factories deep in Germany. Among their escorts were 16 groups of fighters, including 7 groups of P-47 seconds. Major Robert Johnson, who would end the war as the second highest-scoring American ace in Europe, led a squadron of Thunderbolts from the 61st Fighter Group. Their mission: protect the bomber stream during the most dangerous part of the journey, over German territory where Luftwaffe fighters would be most numerous and aggressive. Johnson's squadron intercepted a formation of Focke-Wulf 190 seconds near Leipzig. "Bandits, 9 o'clock high," crackled over the radio. The German fighters were at 34,000 feet, normally an altitude where the Thunderbolt would struggle. But as the Luftwaffe pilots dove to attack the bombers, Johnson ordered his squadron to climb and intercept. "Use emergency power. Keep them off the big friends." What followed demonstrated the critical advantage the modification provided. The P-47 seconds, which once would have been outclimbed at this altitude, surged upward to meet the attacking Germans. The Focke-Wulfs, expecting to face the familiar limitations of the Thunderbolt, found themselves instead confronting American fighters that could match their performance envelope even in the thin air above 30,000 feet. The Germans broke off their attack, losing 3 aircraft without damaging a single bomber. Similar scenes played out across the German skies throughout Big Week. German pilots reported encountering P-47 seconds performing in ways their intelligence briefings had indicated should be impossible. Captured Luftwaffe documents later revealed the confusion this caused among German commanders. One intelligence assessment noted, "American P-47 seconds are now operating effectively at altitudes where previously they showed performance deficiencies. This unexpected development requires tactical re-evaluation." By the end of Big Week, the strategic balance had shifted decisively. The 8th Air Force had lost 97 bombers, a significant number, but far fewer than planners had feared. More importantly, the Luftwaffe had lost hundreds of fighters, and even more critically, experienced pilots they could not replace. General Kepner's after-action assessment was direct. The ability of our fighters, particularly the modified P-47 seconds, to engage and defeat enemy aircraft at all altitudes where our bombers operate, has fundamentally altered the air war. The Luftwaffe can no longer claim any performance sanctuary where they can attack with impunity. The cost of this victory was measured in maintenance hours and replacement engines. Technical Sergeant Martin Abramson, Chief of Maintenance for a P-47 squadron, documented the toll. After Big Week, 17 of our 24 aircraft required engine replacements. The Supercharger modifications meant these engines were running closer to their limits, and it showed. Valve seats eroded faster, piston rings lost tension, oil consumption doubled or tripled. But as Colonel Zemke had calculated, this was an acceptable trade-off. Aircraft could be repaired or replaced. Trained pilots and bomber crews could not. As the air campaign intensified through the spring of 1944, engineers at Republic Aviation and Pratt Whitney worked to refine the modification, seeking ways to reduce the maintenance burden without sacrificing the crucial performance advantage. By April, they had developed improved components specifically designed to handle the stresses of war emergency power. New piston rings made from more heat-resistant alloys, redesigned valve seats with better cooling characteristics, enhanced oil coolers that could handle the increased thermal load. These components were rushed into production and shipped to maintenance depots in England. Technical representatives from both companies deployed to fighter groups to train maintenance crews on the improved parts and techniques. This collaboration between field maintenance units and factory engineers exemplified the American approach to wartime technology development, a continuous feedback loop of implementation, evaluation, and improvement. One such technical representative was Edward Mitchell, a senior engineer from Pratt Whitney, who had worked directly with Sanator on the original modification. Mitchell travelled between fighter groups in England, collecting data and sharing knowledge. What we're seeing is consistent with our test results, but field conditions reveal things we couldn't anticipate in the lab, he explained to maintenance officers at Debden Airfield. The reality of combat operations, rapid power changes, extreme temperatures, varying fuel quality create stresses we couldn't fully model. Mitchell's observations led to further refinements. The technical bulletins he sent back to the factory influenced not just the P-47's R2800 engines, but future engine designs. The lessons learned from pushing these engines beyond their original limits would inform post-war aviation development, contributing to more powerful and reliable engines for both military and civilian aircraft. By May 1944, as Allied forces prepared for the invasion of Normandy, the modified P-47 seconds had established clear air superiority over Northern Europe. Luftwaffe fighters still rose to challenge Allied bombing raids, but they did so in diminishing numbers and with decreasing effectiveness. The strategic objective of Operation Argument had been achieved. The German Air Force had been crippled, setting the conditions for the successful invasion of France. On D-Day, June 6, 1944, thousands of Allied aircraft filled the skies over Normandy. Among them were 18 groups of P-47 Thunderbolts, now operating primarily in the fighter-bomber role. With air superiority largely established, the Jugs were unleashed to attack ground targets, a mission for which they proved exceptionally well-suited. Their robust construction allowed them to absorb significant damage from ground fire and still return home. Their 8 .50 caliber machine guns could destroy anything short of a tank, and the bombs and rockets they carried could handle even the heaviest German armor. Lieutenant Colonel Francis Gabreski, who would end the war as America's top-scoring ace in Europe with 28 aerial victories, led his squadron of P-47 seconds against German positions near Utah Beach. The Jug was the perfect aircraft for this phase of the war, he later recalled. We could escort bombers in the morning, strafe trains and trucks in the afternoon, and be back for dinner. No other fighter in the inventory could take the punishment the P-47 absorbed from ground fire. I once returned with over 200 holes in my aircraft and an engine still running smoothly. The war emergency power modification proved just as valuable in the fighter-bomber role as it had in high-altitude escort missions. The additional power meant P-47 seconds could carry heavier bomb loads while maintaining the performance needed to evade enemy fighters. It allowed for steeper climb-outs after attack runs, reducing vulnerability to anti-aircraft fire. Most importantly, it provided a crucial performance margin when pilots needed it most when damaged, heavily loaded, or caught in tactically disadvantageous positions. As Allied forces pushed inland from the Normandy beaches, P-47 seconds ranged ahead, attacking German transportation networks and armor concentrations. During the breakout from the beachhead in Operation Cobra, Thunderbolts played a decisive role in trapping German forces in what became known as the Falaise Pocket. On July 25, 1944, the 405th Fighter Group caught a German armoured column retreating near Street Low. In a single afternoon, they destroyed 66 tanks and over 200 other vehicles. This devastating effectiveness against ground targets represented another dimension of the P-47's versatility, a characteristic that stemmed directly from the robustness engineered into both the airframe and the engine. The R-2800, with its modified Supercharger, could deliver the power needed for ground attack missions, while maintaining the reserves required to escape when necessary. The original high-altitude escort fighter had evolved into perhaps the most effective fighter bomber of the war. By the autumn of 1944, the evidence of the modification's impact was undeniable. Technical analysis of combat reports showed that P-47 squadrons, equipped with the modified engines, achieved 22% more aerial victories and completed 35% more ground attack sorties than comparable squadrons before the modification. Maintenance records confirmed the trade-off. Engine replacement rates had increased by 40%, but combat losses had decreased by nearly 30%. The strategic implications were profound. The modification had helped secure air superiority at a critical moment in the war, protecting the vital bombing campaign against German industry and enabling the successful invasion of Europe. The cost in maintenance hours and replacement engines was significant but acceptable given the strategic returns. This balanced trading material for lives, accepting increased maintenance requirements for tactical advantages, exemplified the American approach to warfare. As the Allies pushed toward Germany in late 1944, the air war entered a new phase. The Luftwaffe, critically short of fuel and experienced pilots, could no longer mount effective opposition to Allied air operations. German industry, under relentless bombing, struggled to produce new aircraft. The skies over Europe increasingly belonged to the Allies, with P-47 seconds continuing to play a central role in both air superiority and ground attack missions. December 16, 1944, brought one final test of Allied air power when Germany launched its last major offensive in the West, the Battle of the Bulge. Initial German success came during a period of bad weather that grounded Allied aircraft. When skies cleared on December 23, waves of fighter bombers, including hundreds of P-47 seconds, attacked German columns advancing through the Ardennes. The effect was devastating. German tanks, trapped on narrow roads and without air cover, were easy targets for the marauding Thunderbolts. General George Patton, commanding the Third Army's relief effort toward Bastogne, noted in his diary, "The weather has cleared and the air is in. They're knocking the hell out of the Krauts." His assessment was accurate. Over the next week, P-47 seconds and other Allied aircraft destroyed over 500 German tanks and more than 6,000 other vehicles. The Ardennes offensive ground to a halt, broken by a combination of stubborn American ground resistance and overwhelming air power. In the aftermath of the Battle of the Bulge, as Allied forces resumed their advance into Germany, Robert Sanator received a letter from Colonel Hubert Zemke. Now recovered from injuries sustained when he was forced to bail out over Germany and subsequently captured, Zemke had been repatriated in a prisoner exchange. His letter was simple but profound. "Your modification to the P-47 Supercharger saved countless lives. Every pilot who flew the Jug in combat owes you a debt that can never be repaid. What you accomplished with that dangerous idea changed the course of the air war." Sanator kept the letter, but never publicly claimed credit for the modification. Like many who contributed to the war effort through technical innovation, he considered his work simply part of the collective endeavor to defeat fascism. After the war, he continued his career in aerospace engineering, working on jet engines and eventually contributing to early space program propulsion systems. The lessons learned from pushing the R-2800 beyond its original limits informed his approach to these new challenges. The war emergency power modification to the P-47's turbo supercharger represented more than just a technical achievement. It embodied a philosophical approach to engineering and warfare that prioritized practical effectiveness over theoretical perfection. American engineers like Sanator and Kartveli recognized that wartime conditions demanded immediate solutions that could be implemented quickly across the force, even if those solutions created new maintenance challenges or reduced system longevity. This pragmatism extended beyond the P-47 program to encompass the entire American war production effort. Factories across the United States produced weapons and equipment designed to be good enough rather than perfect, manufacturable in massive quantities, and maintainable by personnel with minimal specialized training. The result was an overwhelming material advantage that, combined with the courage and skill of the men who operated the equipment, proved decisive. As the war in Europe moved toward its conclusion in the spring of 1945, the modified P-47 seconds continued their dual role as fighters and ground attack aircraft. Their contribution to the final victory was measured not just in enemy aircraft shot down or tanks destroyed, but in the strategic freedom their capabilities provided to Allied commanders. Air superiority, achieved and maintained in part through the enhanced performance of the Thunderbolt, allowed the Allies to move troops and supplies without fear of air attack, to observe enemy positions at will, and to strike targets deep behind German lines. May 8, 1945, brought the surrender of Germany and the end of the war in Europe. As P-47 squadrons stood down from combat operations, maintenance crews conducted final assessments of the aircraft they had kept flying through years of intense combat. The evidence of the war emergency power modification's impact was written in the maintenance logs and the engines themselves. Higher wear rates, increased oil consumption, more frequent component failures, all testified to the stresses the engines had endured. Yet these maintenance challenges had been more than offset by the tactical advantages gained. Technical Sergeant Richard Donahue, Chief of Maintenance for a P-47 squadron that had operated in both the escort and ground attack roles, summarized it simply: "We wore out engines instead of losing pilots. I'll take that trade any day." This sentiment was echoed across maintenance units that had worked tirelessly to keep the modified Thunderbolts flying despite the additional strain on their engines. The legacy of the P-47's Supercharger modification extended far beyond the end of hostilities. The lessons learned from this wartime innovation influenced post-war engine development, contributing to more powerful and reliable power plants for both military and civilian aircraft. Engineers who had worked on the modification program, including Sanator himself, applied their knowledge to new challenges in the jet age, bringing the same pragmatic approach to pushing technological boundaries. More broadly, the story of the modification exemplified how American engineering philosophy had evolved during the war. The emphasis on practical solutions over theoretical perfection, on mass production over craftsmanship, on standardization over specialization, These principles had proven devastatingly effective in the conflict and would shape American industry for decades to come. The P-47's Supercharger modification was just one example of this approach, but a particularly illustrative one. In 1972, at a reunion of P-47 pilots in Dayton, Ohio, several veterans sought out Robert Sanator, by then retired from a distinguished career in aerospace engineering. Though he had never sought recognition for his wartime contribution, word had spread about his role in developing the War Emergency Power modification. The pilots wanted to express their gratitude personally. Colonel Raymond Knight, who had scored 5 of his 7 aerial victories in a modified P-47, spoke for the group. "Mr. Sanator, we wanted you to know that your work saved our lives many times over. When we hit that emergency power and felt that surge of strength, we knew we had a fighting chance, no matter what the odds. Engineers like you, who never fired a shot, won this war as surely as any of us who did." Sanator, characteristically modest, deflected the praise to the maintenance crews who had kept the aircraft flying despite the additional strain the modification placed on the engines. The exchange captured something essential about the American war: the seamless integration of technical innovation, industrial production, skilled maintenance, and courageous operation that had ultimately overwhelmed the Axis powers. No single element would have been sufficient alone. The modification to the P-47's turbo supercharger represented just one thread in this complex tapestry, but a critical one that had helped change the course of the air war at a decisive moment. As the reunions continued through the years, with fewer veterans attending each time, the stories they shared increasingly focused not on the technical details of the aircraft they had flown, but on the men who had maintained them. Lieutenant William Dunham, who had scored 8 aerial victories flying P-47 seconds with the 356th Fighter Group, made a point at each reunion to toast the ground crews. "To the men who never got medals but who kept us in the air, the real heroes of this war." This recognition of the critical role played by maintenance personnel reflected the reality of modern warfare. The technical complexity of aircraft, like the P-47, especially with modifications that pushed them beyond their original design parameters, meant that success in combat depended as much on skilled maintenance as on piloting ability. The War Emergency Power modification had made this relationship even more pronounced, creating a partnership between pilots and mechanics that was essential to exploiting the capability without destroying the engines that provided it. By the 1980s, as the World War II generation aged, aviation historians began to document more systematically the technical innovations that had contributed to Allied victory. The P-47's War Emergency Power modification, long overlooked in favor of more dramatic technological developments like radar or the atomic bomb, received renewed attention. Interviews with surviving engineers, pilots, and maintenance personnel revealed the full significance of what had seemed, at the time, like a modest enhancement to an existing system. Dr. Richard Hallion, in his comprehensive history of American fighter development, identified the modification as a perfect example of American pragmatic engineering, accepting increased maintenance requirements and reduced component life in exchange for immediate tactical advantages at a critical moment in the conflict. This assessment captured the essence of the modification's significance. It was not just a technical achievement, but a philosophical one, exemplifying an approach to warfare that prioritized present effectiveness over theoretical perfection. As the 21st century dawned, with most of the men who had designed, built, maintained, and flown the P-47 Thunderbolt now gone, their legacy lived on in both tangible and intangible ways. The few surviving P-47 seconds, carefully preserved in museums around the world, stood as physical reminders of their achievement. More significant, though less visible, was the engineering philosophy. They had embodied the willingness to push beyond established limits when circumstances demanded, to accept necessary trade-offs, and to implement immediate solutions rather than waiting for perfect ones. In a world of increasingly complex technological systems, this philosophy remains relevant. The story of how one mechanic's dangerous idea transformed a capable fighter into a dominant one, how that transformation helped secure air superiority at a critical moment in World War II, and how the maintenance burden this created was accepted as a necessary cost of victory. This narrative offers enduring lessons about innovation, pragmatism, and the balance between theoretical perfection and practical effectiveness. The P-47 Thunderbolt, already one of the most successful fighter aircraft of World War II, became even more formidable through the application of American engineering pragmatism. The war emergency power modification that pushed its massive R-2800 engine beyond established limits exemplified an approach to warfare that would help secure Allied victory, not through revolutionary new weapons, but through the continuous refinement and maximum exploitation of existing ones. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.